So we're on the back side of the notes, and it starts off with the question, why do we graph? And we should all, this is what I want you to learn today, why do we graph? To represent the infinite amount of answers that exist to an equation with two variables, okay? Now, you saw how we graphed on the other one. We just started thinking like, let me, what answers work, right? Like we just started thinking of the answers that work, and we came up with coordinates, and then we graphed them. Is there a more organized way than just thinking of the answers that work? Yes, we have the steps right here, okay? Now, we're going to spend a whole month on graphing. It's a huge part of algebra, graphing lines, all right? I really want you guys to understand this, so please pay attention. And we're going to learn different methods of graphing lines. This is the very first one, the most foundational method of graphing lines, by thinking of the solutions, because after all, the line represents all the solutions. So I give you some steps right here. Step one is to rewrite it in function form. Now, we've never seen this word before. We need to memorize the definition. What is function form? The word form means the appearance, the way it looks, right? If you fill out a form, usually it's organized. It says name, address, date. A form is organized the way it looks, the organization of it. So function form is when you rewrite your equation in a certain manner, and what manner to have y by itself. So function form means get y by itself. In other words, that means solve for y. So if you look at number 1 down here on the practice, is y by itself?
No.
Right here. Yeah, it says y equals. So that is what we call function form right there. Now sometimes you won't have it in function form. You might have like a 2 in front of the y, and you'd have to divide by 2, divide by 2, divide by 2 to get it in function form. So sometimes step 1 is done for you. Sometimes you actually have to do some math to get it in function form. What does function form mean again, guys? Function form, what does it mean? Get y by itself. Get y by itself. Okay, that's the first thing we need to know. Function form means get y by itself. Now, step 2, after you get y by itself, on number 1, y is already by itself. Step 2 is to make an input-output table, also known as an XY table. So this is what it looks like. Everybody draw this right next to step 2. Go ahead and draw like a little T right there. And let's put an X on the left side and a Y on the right side. And that is what we call an input-output table. It's an XY table. And we're going to plug in 3 easy numbers, and we're going to plug them into the X side to the left. So we're going to plug in 3 easy numbers, most of the time 0, 1, and 2. So we need to know this, that this is step 2, writing our XY table or input-output table and plugging in 3 easy numbers, most of the time 0, 1, and 2. Okay, so once you plug in 0, 1, and 2, you're going to get answers, and those answers are going to be the outputs, which are the y values. And you're going to end up with coordinates. And then you're going to graph those coordinates, and you're going to draw a line through your 3 points, and you're going to put arrows on it. Now, I know that sounds like a lot, but let's just work through it. So step 1 is to rewrite it in function form. Again, function form is just solving for y, getting y by itself. And as you can see, number 1 already has y by itself. So step 2 is to make an input-output table. So let's all do that right here. Let's do a little t, put an x on this side, a y on that side. And it says most of the time plug in 3 easy numbers like 0, 1, and 2. Now, I'm going to take the 0 and I'm going to put it in to the x, right? Why am I going to put the 0 into the x? Why not into the y?
Because it's on the X.
Because it's on the x side. Thank you. So we're going to take that 0 and put it right there. Now, you could show your work and say, okay, 0 take away 2. What do I get when I do 0 take away 2?
You get negative 2.
You get negative 2 as an answer.
Yeah.
Okay, so when I plug in 0, I get out a negative 2. And this is an actual coordinate, guys. Okay, so you could actually graph 0 on the x, 0 on the x, negative 2 on the y, and put a dot right there. But of course, we want to plug in the rest of the numbers. The 1, we're going to plug in for x. Why? Because it's on the x side. We're going to plug in the 2 for x. And see, when we work it out, we get a y answer. So that's why we call these guys inputs, because we're putting them into the x. And when we work out the math, we get an output, and that output is the y. Right? On the 0, we plugged in 0. 0 take away 2 is negative 2, and it says y equals negative 2. So the output, negative 2, is really the y value that we get. All right? Let's do the next one. And you know what? For the sake of doing this a little quicker, let me take the 1 and do it in my head. 1 plugged in right here. What's 1 take away 2?
Negative 1.
Negative 1, right? So the answer is negative 1. And that's another coordinate. Let me do this in my head. Plug in 2, the input 2, into the x. What's 2 take away 2? 0. So you guys see how easy it is to do inputs and outputs, to plug in your x values and pull out your y values? Now let's plot those other points. The coordinate 1, negative 1, 1 on the x, negative 1 on the y is right there. Let's put a dot there. And then let's go to the last coordinate, 2, 0. 2 on the x, 0 on the y. So you stay right there. And 2, 0 is right on the x-axis. Ladies and gentlemen, how many points do we actually need to draw a line? 2. Right? I mean, if I have these 2 right here, and if I get a ruler, I'll be able to draw the rest, and it'll be going through it perfectly, right? But I say do 3. That way you could see and be more comfortable if they line up perfectly. So like if you got 1 dot here, 1 dot there, and this middle dot is up here, you know that's messed up. That's not a line. You guys follow me? Okay, so we're doing 3 just to feel more comfortable that we did it right, to be able to see if they line up. Okay, so anyway, you draw your line through those 3 dots, put an arrow, and you're done. Okay? And I might as well throw this at you. Let's say you think, oh, that line's too short, and you want to make it longer, and you don't have a ruler. Then you could use the pattern of the points. So check this out. From this point right here to this one, what happens? I go up 1 and over 1. And then I go up 1 and over 1. So I could continue with that pattern of going up 1 and over 1, and I could put a dot right there, right? And I could continue up 1, over 1, up 1, over 1, and I could make the line as long as I want, as long as I need it to be. Okay? Or you could go backwards. You could say down 1 over 1, down 1 over 1, and put a dot here, down 1 over 1, put a dot here, down 1 over 1, put a dot here. So you could use the pattern if you don't have a ruler to get as many dots as you want, to make it as long as you want. Again, what does this line represent? Infinite answers to what? To this equation, right? Now, I mean, if you pick any point on this line, I'm talking about like this. What is this point right here? What is that coordinate right there? That black one.
That's -3.
-3, comma, -5. Now, if this line really represents all the answers that exist to this equation, then that dot is an answer and it should work, right? So let me show you. If I were to plug in -3 for x, let me show you. Plug in -3 for x, and then you're going to have a -2. And if you were to plug in -5 for y, isn't that a true statement? -5 equals -3 minus 2. See how it's true? So this really is an answer. But that's obvious because the line represents an infinite amount of answers. So any point on this line is going to be an answer. I know I'm talking a lot. I apologize. So we have our 3 steps there. Step 1 is to get y by itself. Number 2, is y by itself? No, let's get it by itself. What do I do to get rid of that multiplication of 2? Divide by 2. So check it out. I'm going to divide by 2, divide by 2, divide by 2, divide everything by 2. Kind of like if I had a fraction and I get rid of it by multiplying by the denominator, I multiply everything by the denominator. Same thing here. I want to get rid of that 2. I divide everything by 2. So I'm going to have a new equation, y equals 2x minus 1. Perfect. This is function form. Y is by itself. That was step 1. What's step 2? XY table or input-output table, whatever you want to call it. And we're going to plug in 3 easy numbers. What's the easiest number to plug in? 0 is always the easiest. And 1 and 2 most of the time work, but we're not going to use 1 and 2 all the time. We'll get to one of those examples later. But let's start plugging in 0 into our function form equation. So when I take 0, which is an x, and when I take 0, which is an x, and plug it into the x right here, 2 times 0 is what?
0.
And what's 0 take away 1? Negative 1. So I get an output of negative 1. I want to plug in 1 now. 1 right here. What's 2 times 1? And 2 take away 1? 1. Now let me take this 2 right here and plug it in. 2 times 2.
4.
And 4 take away 1? 3. I do not recommend doing it in your head, right? It's probably better to show, okay, instead, check this out. I want to go 2x minus 1. Let me write it 3 times. 2x minus 1. 2x minus 1. 2x minus 1. And what did we do? We took the 0, plugged it in right there. So you end up with 0 in there. And 2 times 0 is 0, minus 1 is negative 1. That's how we got the output, negative 1 over there. Of course, if you're taking a quiz and you're rushing for time, you don't have to show all this work. You just do it in your head, right? But it'd be nice to show work if you have time. 2 times 1 is 2. 2 take away 1 is 1. 2 times 2 is 4. 4 take away 1 is 3. And that's how we get these outputs right here of 1 and 3. Okay. Anyway, these are answers. These are coordinates. So let's graph them. 0, negative 1. 0 on the x, negative 1 on the y. There it is. 1, 1. There it is. And 2, 3. There it is. Did I do that right? No. How do I know I didn't do it right? It doesn't line up, right? So I did a mistake somewhere. Where is 2, 3 at?
2, 3 is up to 2, and then you do a 3.
2 on the x, 3 on the y. So yeah, that was my mistake. 2, 3 is right there. As you can see, it does line up perfectly. It does have a pattern. If you wanted to make it longer, it's going up 2 over 1, up 2 over 1. You could keep going up 2 over 1 and so on and so on. Or you could go backwards, down 1 or down 2 over 1 this way, down 2 over 1 this way, down 2 over 1 this way. I'm just going to leave it right there with 3 dots. And since they do line up, put some arrows on it, and you know that you feel more confident that you have the right graph. Let's move on. Let's all look at number 6 now. You're going to do all of them for homework, and by the time it's after school, I'll have all the videos explaining all of them. But let's jump to number 6. It's the most interesting one. Why is that? Because when we do step 1, get in function form, we want to get y by itself. We'd have to divide everything by 2. And we end up with a slight problem. Y is by itself. That's function form. That's what we wanted for step 1. 3 divided by 2, I can't really do that. So I just leave it like a fraction, 3 divided by 2. Of course, there's still an x right there. And 8 divided by 2, that one's 4. So this is my function form equation. Y is by itself. It's great. The next step is to make a XY table, an input-output table. And you want to use 3 easy numbers. The easiest number is what? 0. Now, let's first start with 0 and show why that works, because 3 halves, actually anything times 0 is 0. And then 0 minus 4 is what? Negative 4. So we get one beautiful answer, one coordinate. Now, I'm not going to use 1, and I'll tell you why. I mean, I could if I wanted to. But when I use 1, 3 halves times 1, I end up with a fraction 3 halves. And then 3 halves take away 4, I'm going to end up with the output that's a fraction. And I don't really like graphing fractions that are not clean points. You know what I mean? You could do it if you wanted to. But instead of 1, it would be really nice to plug in a number that would make this fraction disappear. 2, the denominator, right? So whenever you have a fraction in front of your x, why not input the denominator itself? So when you input the denominator, so let's not plug in 1, let's actually plug in the denominator 2. And let me show you what happens. So there's my work completely written out. I am plugging in a 2 in place of x. As you can see, there it is in blue. So it was 3 halves x. It's really 3 halves times 2. And when you multiply a fraction by its denominator, it cancels out. And you end up with y equals 3 take away 4. What's 3 take away 4? Negative 1. So your y value, your output is negative 1. And ladies and gentlemen, we already have 2 coordinates right there. That's enough to graph a line. So we could plot the first point, 0, negative 4, 0 on the x, negative 4 on the y. Here it is. Then we could graph this second coordinate of 2, -1. 2 on the x, -1 on the y. There it is. Now, I usually say draw 3 dots doing inputs and outputs. So you could plug in a 4 if you wanted to. That way, it would work out pretty nice. The 3/2 times 4 would cancel and you get an easy output. But how about this? Bless you. Bless you. With those 2 dots, we already have a pattern from one to the other. What is that pattern? How much do I go up?
Go 3 up, 2 to the left.
Yeah, 3 up, 2 to the left. That's the pattern that's going to exist throughout the whole line. So if from this dot I go 3 up, 1, 2, 3, 2 to the left, I end up right here. And let's put a dot right there. And you know what? What is that coordinate? That's the coordinate 4, 2. Now, I know that that's correct. If you draw your line right through it, put some arrows, that's correct. Now, but let me verify that 4, 2 is an answer. 4 is x, 2 is y. If I were to plug it into the original or to my function form, whatever I want, if I plug in the original, x being 4 right here on the original, that would be 3 times 4, that's 12. 3 times 4, that's 12, and then minus 8. And if I were to plug in 2 for y, that would be 2 times 2. That would be 4. 2 times 2. And that would be a true statement. 4 equals 12 take away 8. 12 take away 8 is 4. So 4 really does equal 4. It's a true statement. That does work. Any point on this line will be an answer to that original equation. After all, the reason why we graph is to represent the infinite amount of answers that exist to an equation. So I'll make another video explaining the rest of these questions. How about you guys, for the rest of the class right now, try to follow the steps, get y by itself. What would we do first to get y by itself right here?
Divide by 8. Make the x go on the other side.
Okay, yeah, so if we're getting y by itself, y is the movie star, 2 is the movie star's buddy, this guy's the one we want to get rid of first, right? So I'll do a video explaining the rest, but I want you guys to try it on your own right now.